Alright, hey everybody, I hope you're all having a great day so far. Oh, and I hope you had a great weekend too. Mine has, mine just zipped by, but it was pretty good. My brother had a birthday, so I barely had any time at the computer, so it's kind of nice to have a break from that. But yeah, I'm ready to get back to the 2D Lights project. So we still have some more things we need to do here about the shadow mesh generation. It's turned out to be pretty involved. Oh, did I not even start up Unity? Oh gosh. Okay, well this won't take too long. But the main thing is, well, we found that one weird bug where if a light was below and to the right of a platform, it made a strange shape, so hopefully that won't be too much of an issue. And then also we have to figure out if we want to try and handle collapsed shadows when basically when one of the points is outside the bounds, because at that point A is at the same position as when the shadow raycast hits the boundary, and so you can skip a vertex there. And we can save a little bit of vertice space, and then also here when you're at a corner. That's a weird issue that we'll have to do. And then hopefully when we fix all these problems we'll be able to remove the redundant clockwise test right here, because really we only have to check the first one, or we should have to only check the first one. But because if A equals hit A, then this will actually return nothing. Or it's basically an invalid question. And then the last thing we need to do, more corner stuff, and then we need to figure out how to cache the arrays so that we don't have to create a new array every time we loop through this method, because that's generating a ton of garbage, and I think it does negatively affect the frame rate. But let's just play and see where I left off. Okay, so I think all the lights work. But yeah, there's that. This is the issue right here. So I need to try and figure what's going on. I think I'll just go down to one light. Okay, there we go. So it's like, it's not. Doesn't seem to. Well, no, it is pretty consistent, I guess. So let's see. We can take a look here. So A is first clockwise from the light, so A is right here. So A equals hit A, so we know that, and then B is here equals hit B, so that is to the right. So it seems like what's happening. It works fine over here. It's only when it gets weird. I think what's happening is the mesh should go up to this corner, but maybe it goes down to this one instead, and then the shape just doesn't even make sense. Because it seems to happen, yeah, because right when this light, or this line, passes the diagonal here and hits this side, so then the lights are on opposite sides. Okay, so yeah, and then something weird is happening where the shadow feels like it needs to hit these three corners instead of these three. Okay, well maybe that's because we can't just always... Let's go down to the offending code. Yeah, so right here I do +1, and maybe sometimes I need to do -1. Okay. Oh yeah, and this might be a little confusing, but +1, I mean, doing -1 is the same as doing +3 in since we have this modulo, but you can't really do... Well, I think that negative numbers don't work how you'd expect. Well, I mean, I guess they do work how you'd expect with modulo, but they don't cycle around from 0 to 4 like we want. So you always want to add here. And so this saying corner index minus 1 is equivalent to quarter index plus 3. So that's what I'm going to do here. And I'm obviously adding 1 works how we want most of the time, but I'm going to see if I add 3 here, if that will fix the problem that we had for this one case. Sort of. But still skipping this corner. Yeah, but now this code, and now we basically just are flipped where the weird corner case happens. What would be the best way to do this? So we kind of need to know... let me test this actually one more time. Because it seems like it only happens in this quadrant. Does it? Is it symmetric on the other side though? Okay, no. So that makes me think that it probably is something having to do with, again, clockwise and counterclockwise winding. Alright, so how would I figure out... Well, I mean, I guess it kind of makes sense here because if the shadow is above the light, then we want to cycle around, I think, counterclockwise, which is an issue we're running in here. So maybe I should have this also just return the second corner index. And I'm not sure which ones should be flipped or counterclockwise here. Okay, what's it not like about this? Oh, because I need to set the corner 2 index. Okay, so on the bottom left side, that means hit was on the horizontal side. And then does this actually work? Because, like in our case here, this is actually going to throw an error, but yeah, so let's leave it how it was for now. let's look here, and okay, I'm just going to make sure that this is point A. And we can tell that by when I create the bottoms. Yeah, the left side is A and then the right side is B. So A equals hit A, which, and that's, so that means that this code is kind of a problem. I guess what I really need to do is check if A position Y is less than hit A or B is less than hit B. Because we don't know if one of these is equal to each other. And I gotta do the same thing here. So let's just see what this change does to the algorithm. Probably won't really be anything different, but oh, was that the whole issue? Okay, cool. Yeah, so the thing was happening is because here to check if the shadow should be above the light, we checked only A and hit A's position, but since A and hit A are equivalent at this point because they both are on the border, then obviously it was saying that the shadow should be below, but that's not correct. So now that we check if either A or B is, or if either hit A is above A or hit B is above B, then we always know for sure which side the shadow is supposed to be on. Because if both are equal, then we shouldn't even get to this point. Because that just means it's a mesh with no vertices. So okay, so before I go any further, I'm gonna check if I make this platform also very tall. Edit the sprite just so they match up. Just to make sure there's not any other weird non-symmetric issues. Okay, so there's this weird thing. I think I saw it before, but yeah, if you are exactly in the middle of the collider, then A equals hit B and B equals hit B. Or no, that's correct. A equals hit B. A equals hit A and B equals hit B, and the game doesn't know how to handle that. But obviously it should just draw a line straight through. But it seems like everything else works. Okay, so why don't I leave this platform as a square just to test it. I'll move it up a little bit. Maybe need this right now. Okay, so I got rid of this. Okay, so we kind of know what we have to do here, but it might be a special case. But maybe we should handle this first because this actually produces like some noticeable issues. These would just be like an optimization. Okay, I know you don't need to have this separate corner 2 index anymore. So ideally what I want to do, like this code all still works even with collapsed vertices, but we want to check that if A equals hit A, then we just want to add hit A. and then we'd skip that triangle. Okay, so let's try that. So I'm trying to think. I think that an easy way I can test if A and hit A are the same is just that they hit the same bounds, because I don't think there's any way. Because the only way that they could not be equal is if A is, say, on the left bound, and then the light pushes the ray straight upwards, so it goes in a corner. So I think if I just check if their sides are the same, then that's one way that I can do it and not have to test floats. So okay, horizontal side equals hit A, and A vertical side equals side. Do the same here. And this code still works the same if they're equivalent, so I won't mess with that. So if... maybe I should change this to if they're not equivalent, so I won't have to keep testing for false. If that is false, I know I need to change the variable names too. So, A not bounded. I don't know if these variable names make perfect sense, but so A equals hit A. Or I guess it's opposite now. Alright, so anyway, if A not bounded, then we would add this, and then if B not bounded, we add hit B. Okay, and then how would I... so if they're both bounded, well, that shouldn't ever happen with a 4 vertices shadow. Yeah, so I won't worry about that. So basically, this is the first shadow between A, hit A, and hit B, so this only happens if A not bounded. Oh, except now I need to change the indexes. How would I do that? The thing is that if I'm gonna have to do one for every possibility. Okay, well, let's see. If A not bounded, then, or if A is bounded. Okay, I think I'm starting to see. So basically, if either of these are bounded, then we only have one triangle, and that's just this. So and B not bounded, then we add a second triangle. think that's right. I guess I can try and see if... I'm not sure how easily I'll be able to test this because it's kind of hard to get the correct points this would happen. So I guess here, yeah, A is outside of bounds. So A and hit A are equivalent. And this is a 4-point shadow. Actually no, because this is a 5-point shadow. Can I get a 4-point shadow here? It has to be one that doesn't touch a corner. I guess I can like this. It seems to be working. Alright, cool. So 5 vertices. Again, if A equals hit A, then we just don't add this. And this one's going to be a little more complicated, I think. Similarly, if B goes hit B, then we don't need to add this one. So let's see here. I could maybe simplify this by changing the order of the vertices, but so again, if either of these are the same, we just have to omit a vertice, but the problem is this counter. I'm not sure of a good way that I can handle this without having just different indices for every possibility. Well, the good thing is that it kind of follows a pattern. It's always the first, which is A, and then 2. So I think this might work actually. So we'll always add at least one triangle, which may just be A corner B. And then if either A or B is not bounded, we'll have the second triangle. And then if both are not bounded, then we would, or I'm saying it backwards, so. But yeah, I think this will work. So basically, if we just, if one of those points are not equivalent, then we add one more triangle, and then if both are not equivalent, then we add a third. Oops. I think here will be exactly the same, except yeah, we'll just, instead of adding a second or third triangle, it'd be a third or a fourth triangle. And then of course there's a special case when they're both bounded but on opposite sides. Well, no, yeah, that'll just take care of itself, I think. Okay, so this is actually not quite as complicated as I thought. It's just a little hard to wrap your head around. Oops. And then again, if either, then we add a third triangle. And then if both, we add the last one. Here is, should this be both or should be either. Okay, well actually, see, this shouldn't even run if both are not bounded, which I think can never happen, so... So it's either, yeah, this should be or, actually. Okay, so let's look around and see what happens now. Okay, so already some errors, but... Really? Okay, I'm gonna disable the other lights. It's because I want to actually see what's causing the error. Hey Mimaron, how are you doing? Thanks for stopping by. Alright, so something is up. I'm just gonna make sure that I didn't leave out or make a typo somewhere. It looks like it's all okay. Oh, good to hear. Yeah, I'm doing pretty good too. Okay, so is my... I'm trying to see how I could reference an out-of-bound vertex. Maybe right here. Should I go back to and? That doesn't make any sense. Okay, so let's just test this out. Because I want to make sure that this never runs when both of these are false. Which, logically it shouldn't, but it could be some bug. Okay, false, true, and it just... Okay, so true, false, that's not it. So I guess I should turn this back on. And maybe that will shed some light. Okay, so it already did throw an error right when I started out. Okay, so here we can see we've got 0, 1, 2, 0, 2, 3. And then 4, 5, 6, 4, 6, 7. So it's, yeah, 2, 4 vertex meshes. But obviously one of them only didn't create all 4 vertices. So let's see, which one should that be? Actually, they should have both not created all 4, if I think right. Guess I need a little bit better debugging in here. Okay, so let's see. Bug, log, stream, format. this for the other possibilities, and we can just see what's being created exactly. And it'd be helpful. Alright, Memoran, that's fine. It'd be helpful if I had like a name here so I knew what side this was, just for debugging. Although I guess it doesn't get passed down here, does it? Okay, maybe what I should do is just pass A and B as well. Maybe I have to copy and paste everything again. I guess just part of it. Okay, so yeah, now with the points I should be able to tell if it's the horizontal or vertical side, for instance. So let's try and put it back how it was before. It's like down here in this corner. So it had a 5 vertice face. Let's go one more time. Five vertice face at point. Okay, so this is this left side. So counterclockwise should be bottom. Oh wait, clockwise, so it should be top and bottom, so this is A. Okay, and it does say that A equals hit A because these are the same, and then B equals hit B is false because B is right here, and hit B should be right here. And then here also has a true, so yeah, this should be 3, 4, so that does equal 7, so that makes sense. Okay, so for this 5 vertice, it should have created 2 triangles. So 0, 1, 2 and 0, 2, 3, that's right. So it's the second one that's causing the issue, and it's 2, so yeah, that's the top. So A is here, so A does not equal hit B, that's just correct because it's false right there. But B equals hit B because it's right here in the corner. And so what should be happening is A should also go to about right here. So is it a 4 vertice? Yeah, because it's hitting both this side. Okay, so did I have this logic wrong? No, maybe it is supposed to be and. Well, yeah, I think that is right, actually. Yeah, of course it is, because the only time we'd have 4 vertices and need more than 1 triangle is if both of these are not bounded. Okay, yeah, so I was just kind of going in circles there. Let's try one more time. Sometimes you just need to walk through it. No errors, good. So I'm gonna try all the. First, I'm gonna try to hug it because that usually brings about 6 and 5 vertices. Oh, I was hoping this would be fixed. That's no big deal though. So far, so good. And now I'll go around the edge. Good, and now I'll just try this thinner one because we can get 4 points easier. actually tested hitting 2 colliders, but the good thing about the code I have now is that it basically scales infinitely to the number of segments. It doesn't really care how many colliders are in there. It just takes it one at a time. Okay, so I think I figured that out. That wasn't too bad. Let's clean up these debug logs. Okay, so we're done with that, and so hit A and hit B if they're the same. So we do kind of like we handle collapsing the corners for that, but here there's a special case, which I've seen it a couple times now. Where if red, if the lamp is exactly in the middle, and it's making a 6-point shadow, then the game basically says that there's no shadow. But if you move it just barely to the side, where they're not equal anymore, it fixes it. And that's because the light is exactly the same length as the collider, so yeah, it's kind of weird. But what should happen is A equals hit A here and B equals hit B here, so it should just know to cut out a shadow there. But the problem, I think, is in this code, because again we have to check, we rely on one of A and hit, or A and B being unique. So how should I deal with this? Problem is we don't know the light position at this point, do we? Yeah, we only know the vertices, but I guess I can pass that if I really need to. Because I think that if A and hit A and B and hit B are the same, then we would need to check the light position base and the points position. So, and I kind of want this function to be able to do everything. So vector 2. So let's do it like this. If A position Y and hit A position Y, and again with a floating point, you don't want to just test or just use the equals operator, because due to rounding errors, you might not get values you'd expect. It's just always a good rule to keep in mind. And Unity has this useful approximately function, which is tests if two floating point variables are within an extremely small interval. Okay, so if this happens, then we need to just test A against the light position. So it'd be if A dot position dot Y is less than light position. Is there a better way we can do this? We're gonna have to kind of copy this here. Let's see. Both. Oh wait, let's change this to like use light. And then I kind of want to do like a either or based on if this is true or not. Let's do it like this actually. So bool above equals false. Okay, and then if we want to use light, then above would equal a position y is less. Oh wait, that should be the other way around because the light would want to be below. Yeah, so I want to use less than signs just to keep things consistent here. And then otherwise we'd use the hit positions like normal. I guess we could do something like this. I don't know, I was gonna use the ternary operator, but I don't really like that too much. This makes sense, I think. So basically if both A and hit A and B and hit B are the same, then we use the light position to see if the shadow is above or below the light. And based on that we set the corner index, and we'll do the same thing. Oh, except this is horizontal, so this should be to the left, actually. We'll just do the same logic here, except with the X positions. Wait, I'm confused here. No, I had it right, because here we're checking the horizontal side, but then the Y position, so... This is... Oh yeah, see, this is if they're on opposite horizontal sides, so the shadow is either above or below, so I was right the first time. Sorry, it's been a long day. Okay, and then this is to the left. I gotta switch all this to use X instead of Y. And I have a feeling I might have this backwards, but it'll be easy to test. Okay, and then if to the left. Okay, so I think we're all set here. Okay, something wrong. Oh right, I need to pass the light position. It's a little annoying because now I have to pass that all the way down to this function, but can't be helped. Oh, well, I don't need to pass the light position because the light position is always 0. Of course. That's like one of the main things about the system. Okay, so all I have to check here is if... we could just go if 0 is less than the A, but I think actually makes sense. It makes more sense if I do that. So the position is positive. Is that correct here though? Well, I think I might have this wrong because it's to the left if it's... Yeah, I think this should be flipped now that I think about it. Because it's... If X is negative, that means it's shifted to the left, and then if A is to the left of the light, then the shadow is to the left of the light. So this might... I think this will fix this specific case. Oh, it doesn't. That's interesting. Do I have it backwards after all. Okay, now why is it being weird? I didn't change anything about this code. Okay, I think it is. Yeah, okay, good. The weirdness is just when we're in the exact middle. Okay. I was hoping I didn't break something else. But it seems like it only happens on some of the sides. But yeah, so something is wrong with that code. But now that I think about it, if the segment is diagonal, then this doesn't fix the issue. So we still do need the light position, I think, but we need to find, instead of using A, we need to find a midpoint between them, actually. But I guess that's not difficult to do. Just gotta find the average, and if that is less than 0, maybe it should be flipped. The reason I know you have to find the average is because we need to find the point either directly above or beside the light. Because if the line is diagonal, it's possible, I think, that A could be, for instance, below the light, but then the line is actually above the light because B is so high up. But if you find the average, then that's not an issue. Well, actually, I'll leave this code how it was as less than, and oh well, no, this average wouldn't make any difference. And this should be a plus, not a minus. I was gonna say, we'll just test it with this code, but if the x's are the same, which they are right now because the lines are all straight, then obviously we'd still have the same problem. Okay, so, oh, I just saw it again. So if it's on the vertical side, it seems to just not make any shadow. So let's actually put this in the middle just so I can do this easier. Oh, they're still gonna create shadows actually. Try to get a lantern and then move this over. Okay, so now it doesn't do the weird zigzag shadow, but it's obviously not working how we want because it doesn't create a shadow. So what is the issue here? I can probably fix this also by make it more efficient by just checking the sides if they're the same like I did before, but I'm not going to worry about that right now. Okay, so let's see. What do I want to happen in this case? Let's just walk through it. So here, we've already casted an A equals hit A and B equals hit B. And so what should happen is the game detects that they're the same, and then it averages here and sees that the light Y is negative, so it is less than that. Oh wait. No, the light is greater than. Okay, because this isn't 0, that makes sense. So the light's Y position is greater than, so what would happen there? Or, yeah, this is negative because it's below the light. So that means, so correctly it says that the shadow is not above the light. And so that would give it quarter index 3, which going clockwise from here is this corner. So maybe that's not how it should work. Wait, what is corner 0 actually? No, let me make sure. I thought it was up here. Oh yeah, right here. So corner 0 is negative. So it's the bottom left. Okay, so yeah, this is corner 3. So that is right. Correct? Yeah, so it's not above, so corner 3, and then it goes to corner 0. So it should be A, and then hit A. Yeah, so that's A, then hit A, then the first corner, then the second corner, then B, then hit B. Oh, and for the top, A is over here, so. Yeah, because it's clockwise, that's correct. So A, then hit A. Oh wait, A hit A the same, and then the corner, second corner. Okay, so that is right, so what's it not doing? Okay, so I'm gonna re-enable this. I guess if both are true, then it would just, see, it should just add A and then the corners and then create 2 triangles. So I'm a little confused on why the game is confused. So it doesn't see it as a 6-point vertex, or a 6-point, apparently. Oh, you know what's happening? It's this part. The part where we check the triangle winding. If A equals hit A and B equals hit B, then both of these will give bad results. So how will I test this? So I actually need to know this code, or this information, before I get to add vertices, so I guess I should calculate it up above. And then we'll know, we can test cold now. or is visible equals false. And then if A not bounded, we can test the first triangle. Yeah, then is visible equals this. Else if B not bounded, then is visible equals this, because we have to check clockwise on the second triangle. And then if they're, I guess else if they're both bounded, well, I don't have to do this actually, because yeah, if this is true, then it'd go here. So the only way I'd ever get down to this is if both are false anyway. So is visible equals. So I guess I just need to check that the A and B are on opposite. Well, basically that they are not on the same side. Equals A dot hors side. So it doesn't have to be equal, they just have to be either the horizontal or the vertical side has to be different. So in other words, yeah. But yeah, if they're, so yeah, it's not either has to be different, they both have to be different. Or zero. They both have to be different or zero. Okay, so it's kind of confusing. So let's see, equals 0 or B. Okay, well actually easier way to do is just check that they're not equivalent, so. A dot vertical side does not equal B dot vertical side. Okay, so let's test a couple things. So yeah, A and B are both bounded, but they're on different sides vertically. Oh, but yeah, they have to both be in, if either is 0, that's okay. Yeah, so that would return. This code isn't good enough because say A is on the left side, so it's -1 horizontally but 0 vertically, and then B is +1 horizontally but 0 vertically, then this would return false because A does not equal B, but they both have the same vertical. So it's actually A dot horizontal side equals 0 or side equals 0. Alright, this is redundant. Yeah, because either A equals 0 or they're different. Okay, so let's test that same thing again. So A is -1, and then B is +1. So this is false, but this is true, so this side passes. But then they're both 0 here, so A is true, or this part is true. So that's good. And then let's test another weird one. Let's say they're both on the left side, but B is in the corner. So this part is false. And even though this part is true, it would still not pass. Okay, so I think this is sufficient. And then of course if is visible get rid of that comment. Then we'd add the vertices. Now do I want to pass this code on? I guess I might as well so I don't have to calculate it again, even though it's not very much. Yeah, let's change this so this A not hit A is pretty much what this means. Alright, so again, let me just walk through this. So if the A triangle is valid, then we check if it is clockwise, and if that's true, then we do have to add something. But if A is bounded but the B triangle is valid, then we check that one. And then if both A and B are bounded, then we need to see if they're on opposite sides of the bounding area. Okay, so yeah, I think this is good. Hopefully. Yeah, the issue before, of course, was that when we put the light here, it just wasn't even going to the code that was creating the shadows. Now I think it should. So if I set this to 0. Oh, come on. Disappointment. Alright. But it still looks like that code isn't running at all, so something must be wrong here. Okay, so let's just do something like this. Out both points here. Oops. Now we can see, well, I guess we'll check two things, if we even get to that code, and then what their sides are. Okay, so we are right now, but we actually care about when it's outside. Okay, so it says A is -1 and B is -1. That doesn't make any sense. This is saying they're both on the left side. Does it have to do with this part? Find B first. Yeah, we did that backwards, but so I'm just gonna clean this up. So we obviously get to this code, which is fine. So we check, and this is a 0 edge case, which basically means that it's either completely horizontal or vertical, so that doesn't apply to us. Oh, actually it does, because it's always going to be... Oh no, never mind. So what is happening? A and B are the same. Not hit A and hit B, so it's something here where it finds A and B. So they're both not in bounds, so it goes to this, and it's, yeah, testing that they're, again, that they're on opposite sides. Yeah, which is the same as here. So, yeah, we don't actually need to test that they're on opposite sides, we need to test... Okay, so right now I'll just say true, but we need to... Actually, we need to see if the shadow is clockwise or counterclockwise at that point. So something is happening here. So neither is in bounds. See if the segment line intersects. So it starts at A and then goes to the tangent. Okay, so maybe instead of... Okay, I see the problem now. Because it's just starting at point A and then trying to move along, but it's just going to return point A again. So I think I should do point B and then do the negative tangent. See if that fixes the problem. Sort of. I guess we made progress. It's interesting here that for some reason it... Oh, it's because we don't test clockwise. Okay, so it actually works perfectly on this side, which is kind of funny. That makes me think that I need to flip these signs again. Oh, wrong light. Oh. So now it's backwards. Okay, so something else must be wrong with my logic here. Okay, so if they're on opposite horizontal sides, then we test their Y positions, and if they're about the same, we need to go based average is above or below the light. So yeah, if the average is above, then that, yeah, this would be positive. And if it's to the left, well, this is actually backwards, isn't it? Maybe this... Yeah, this variable should just be called to the right. Yeah, because the second corner, or corner number 2, is the top right. Okay, yeah, so the variable was backwards. Or the naming was backwards. Oh gosh, I'm almost out of time, but I really want to finish this bug. Just see what's going on here. It's kind of the same issue. It's weird that it works when I reverse it. So it just says there's 2 triangles. Okay, so it's a 4 vertice. Okay, that's different. So it says it's a. So the reason is because the 4 vertice function here is like taking over when it should let the 6 vertice one go. So in our 6 vertice, what's happening is, yeah, the A horizontally is in 0. So it goes down here, and it says vertically is, oh wait, yeah, sorry, I did it backwards. Horizontally, it's at -1. So I think what I have to do is just say, make sure that, again, that A and hit A are, oh no, that's not true. I think the easiest way would maybe just to make sure that A does not equal hit A again. Should I just pass this then? Okay, instead of passing these variables, maybe I should just have a little helper function here. Is equivalent. So I don't want to say equal, but because it's just integer comparison, so it's not going to slow down the game a whole lot to calculate this a few times. Horizontal side equals other. So I always test if they're distinct, so let's rename this. Did I spell that right? Okay, so now again we just have to flip this. Okay, so let's see. A is distinct with hit A. So instead of having to pass around these variables all the time, we'll just do that. Now I don't even need to cache those values. Okay, here I will want to because we use it a few times. For vertice, so yeah, so I want to return that these are the same, and A is distinct with hit A. Oh no, we actually have to test both because, yeah. yeah, as long as one of them are distinct, then this is fine. So now this will fall through to the 6 point. I hope that this 5 vertice shadow won't trigger. I don't think it will because it tests if they're on certain preset sides. Okay, good. The 4 point shadow still seems to work fine. And if I set this to 0, oh no, it still doesn't work. Okay, so yeah, it's still doing a 4 vertice. Did I get the logic wrong here? So this should turn true if... Hey, wait. Hit A and hit B should not even be on the same side. So that makes me think that the problem is somewhere else. Yeah, because the whole point is that hit A and hit A are the same, and B and hit B are the same, and they're on opposite sides if they got this far. See if I can see a pattern here. I just want to test this out. So I'm going to take out that code I added because it shouldn't be needed. Again, it works perfectly inside. So, okay, well now it's doing a 6 vertice. Okay, so I guess I was just reading that wrong. Yeah, so A and hit A are the same, and B and hit B are the same. Okay, so I don't know, I just was... Oh, probably because the debug thing was not at the bottom, so... I hope I didn't just waste all that time, but... This is false, false. Oh yeah, because they're equivalent, that's why there's only 2 triangles. Which is right, but it's not picking the right 2 triangles. And I should print out the corners. I'll have time to fix this, but I just want to see what happens. Okay, yeah, so now it's saying the triangles are 3 and 0, which is right. So, where's the issue? So the first triangle, maybe it's something here. So yeah, 0, 1, 2, which is right here, and then 0, 2, 3. When I go underneath, it works fine. The triangles are 1, 2. And when I flip, they should go to the other side. And they do, but for some reason the game's not happy. Yeah, so it should be A, then 3, 0, then B. I don't know. But yeah, I'm already 12 minutes over, so yeah, thanks everybody for coming by and watching. Sorry we couldn't finish this, but figure it out tomorrow. I'll be back probably around 8:30 Eastern time, and we'll continue where I left off. Again, thanks everybody for watching. I do appreciate you coming by, and I hope you all have a great night. I hope to see you tomorrow. Bye bye.